Hi, welcome to this lab on OSPF multi-area. I believe you understand what OSPF is. OSPF is Open Shortest Path First, which is a link state routing protocol. So OSPF actually has advantages that it implements what is called area. So in our previous lab, we talked about OSPF single area, how OSPF single area works and how you can configure OSPF single area. We're just going to make some slight improvement on single area, where here we're going to implement a multi-area OSPF. So when you look from the topology here, we have got area 0, which is the backbone. Area 0 is the backbone area. Then we also have area number 14, then area number 45. From the OSPF theory, we know that all areas should be connected to our backbone. Like when we want to make sure communication between different OSPF areas, we must make sure that all the areas are connected to the backbone. But when we look from this our topology, we see that area number 45 here is not directly connected to the backbone. There's a area between, that is area 14, between area 45 and area 0. So how will we be able to make communication between area 0 and area 45? Because area 0 and area 14 will be able to communicate automatic, because we know any network connected to the backbone, all network must be connected to the backbone. So where router number 1 here will act as the ABR, area border gateway, between the backbone and the area number 14. So actually this is the practical we're going to configure, and by the end of this session we will be able to see if all these PCs, PC1 and PC on area number 45 and area number 14 should be able to communicate without any difficulty. Then also, at the end of the practical, we are going to modify the priority of router number 1 so that it becomes a permanent DR. So we're going to give it a priority of 255. We know that when DR election is being done, higher the priority, that is the higher value, indicates a higher priority. Like let's say 255 here. So a router with priority of 255 will act as the DR. So all those concept is important to understand, because now when you configure them, you get to grasp them well. So we are going just to start with our lab, and we are going to configure our routers. We are not going to configure most of the things like the security, because I believe those ones we configured in our previous lab on OSPF single area. So in this part, we are actually going to just implement OSPF multi-area. So we're just going to implement the most important parts in this lab. So we are going to start with our router number 2 here. Enable, then config terminal. First of all, we must change the name. So host name here, this one will be router number 2. After that, we get the interfaces. We have got 2 interfaces. That is interface gig 0/1 and also gig 0/1. So let's configure the interfaces. So interface gig 0/0/0. We're going to give it IP address of 10.10.10.2. This is /255.255.255.0. Then we bring that interface up by telling it no shut. You can see it has turned to green. Then we go to interface gig number 1 that connect to PC. IP address here will be 192.168.2.10, a mask of 255.255.255.0. I tell it no shut to bring the interface up. Also, we know that also we have got a virtual interface on these routers, that is loopback. And no loopback help us now in troubleshooting our networks. So we are going to give them the router's loopback interface. So interface loopback 0. So IP address will be 2.2.2.2. There's a mask of 255.255.255.255 dot. Because it is a /32, everything will be 255.255. So we are done with this router, the interfaces. We come to this PC and give it IP address and the gateway. Sorry, there is a mistake I've made here. Actually, gig number 1 here is supposed to have an IP address of .2, not .10. .10 is for the PC. So go back to that gig 1. Give it IP address of 192. It is .2. After that, we come and give the PC IP address now. We should be able to take, so 192.168.2.10. 10, I mean. Gateway will be 192.168.2.2. Then we go to router number 3 here. Enable. After you enable, tell it config terminal. Then enter the interfaces. So interface gig 0/0. IP address is 10.10.10.3. Mask of 255.255.255.0. Then we bring the interface up, tell it no shut. Interface already up. Then we go to gig number 1. IP address will be 192.168.3.3. Mask of 255.255.255.0. Bring the interface up, tell it no shut. See the interface up. Then you give configure the loopback interface. So interface loopback 0. IP address will be 3.3.3.3. Mask of 255.255.255.255. After that, I also give the PC IP address. So 192.168.3.10. Gateway here will be 192.168.3.3. Then now we didn't change the name of this router, so exit. So let's give it a host name of router number 3. We are now on router number 1. Enable config after that, give it a host name of router number 1. Then we bring the interfaces. We configure the interface with IP addresses. So interface gig 0/0. IP address here will be 10.10.10.1. Mask of 255.255.255. dot 0. We bring it up, so tell it no shutdown. So the interface is already up. And we also configure this serial interface that connect to the router number 4. So interface serial 0/0/0. IP address here is 14.14.14.1, mask of 255.255.255.0, and you tell it no shut. So the link will only be up after we also enable that on the other side of the link. That's when the link will be brought up. Before we do that, let's just configure the loopback interface, loopback 0. IP address is 1.1.1.1, mask of 255.255.255.255. So that's good. Now we are on our router number 4. Enable config terminal. Then host name here, this is router number 4. On router number 4, we have got 3 interfaces, interface serial 00 and serial 001 and gig 00. So interface, let's put it where we can see it well. So interface serial 0/0/0. IP address here will be 14.14.14.4, mask of 255.255.255.0. Tell it no shut to bring it up. See, now it has turned to green, meaning that we've brought our interface up. Then we will also need to bring this other interface also up. So configure the gigabit interface. So interface serial 0/0/1. IP address is 45.45.45.4, mask of 255.255.255.0. Tell it no shut to bring the interface up. So interface G0/0. IP address, its IP address will be 192.168. That, then tell it no shut. The interface should be up. As you see, it has turned to green. Now we are on this our other router number 5 here. We have not configured loopback on this router. This is router number 4. Need to configure a loopback interface, loopback 0. IP address is 4.4.4.4, mask of 255.255.255.255. That's it. We are now on router number 5, our last router. Enable config terminal to enter the global configuration mode. After that, enter the interface serial 0/0/1. Sorry, interface serial 0/0/1 1 IP address here. The IP address was 45.45.45.45.5 mask of 255.255.255.0. Tell it no shut to bring it up. You see the link is already up. Then you configure the loopback interface loopback 0. IP address here is 5.5.5.5 mask of 255.255.255.255. Then lastly, we are on the interface that connect to this PC number 3. So that is gig 00. So interface gig 0/0. IP address here will be 192.168.5.5 mask of 255.255.255.0. Tell it no shut. The link is up. Let's give this PC IP address. Its IP address is 192.168.5.10. The gateway will be 192.168.5.5. And that's done. Also give this PC number 4 here. The PC for router number 4. IP address of 192.168.4.10. Gateway will be 192.168.4.4. So we are done with the IP addresses. Now, after that, we now need to embark on now configuring OSPF. Before we do that, we are going just try to configure and check the connectivity. So while on this PC, we want to configure the interfaces up to the router number 1. So ping, first of all, its gateway, that is 192.168.2.2. It's able to reach its gateway. What about the interface that leaves that router? So ping 10.10.10.2. It's also able to reach because that router understands the network where that belongs. What about the interface on router number 1? That is IP address of 10.10.1. It doesn't know about that. Means that's the same also. If we try to ping PC1 to this router, it won't be able to go through. So that's now where we now implement OSPF. Let's just be sequential. Let's start with router number 1. On router number 1, we have got how many? Router number 1 is on 2 areas. That is area 0, that's the backbone, and it's area number 14. So we're going to exit. So each router is going to be given a different OSPF number, process number. Like I said, even when we give them different process ID, it should be able still to work properly. So we're going to give each router the process ID according to the number of the number of the router. So if it is router number 1, we'll give it a process ID of 1. If it is router number 2, we'll give a process ID of 2. So router OSPF process number 1. So process number 1 here, we have got several three networks. We are going to configure the loopback and the two interfaces. So network of 10.10.10.0, our wildcard mask will be 0.0.255. Know that wildcard mask is just the reverse mask of the subnet mask. Then we are on area number 0. Another network will be 14.14.14.0, mask of 0.0.0.255, but this one is now on area number 14. You can see that interface here. This interface now is on a different area. Then lastly, we are told yet, okay, sorry, we've configured a different wrong mask. It should be 255, not 24 or 255. Okay, correct. Also, we have also to add the loopback. The loopback will also help us in the communication between different routers. So we are going to add that loopback into area 0. So network of the loopback will be 1.1.1.1 because it's a slash 32. Its wildcard mask will be 0.0.0 and it's on area number 0. We are now on router number 2. Enable config terminal. On router number 2 here, process ID will be router OSPF process ID will be number 2 because it is router number 2. Network here we have got 3 networks, that is 10.10.10.0, wildcard mask of 0.0.0.255. Sorry, add the area here is area 0. Another network will be one network of 192.168.2.0, mask of 0.0.0.255, and it's on area 0. You can see here we have received our full state here. The OSPF has exchanged the LSS, and now the state is full with our neighbor here. Our NBR here will be a 1.1.1. That is for the loopback. Neighbor is for the loopback on router number 1. So also this one also loading is done. So also configure loopback. So network for the loopback will be a network of 2.2.2.2, mask of 0. Wildcard mask of 0.0, and it's on area number 0. We are now embark on router number 3. Enable config terminal, process ID router OSPF process is number 3. And process number 3, we have got we are going to connect to 3 networks. So that is network 10.10.10.0, mask of 0.0.0.255 is on area 0. Then we add the network where the PC belongs, so 192.168.3.0 area. A wildcard mask of 0.0.0.255 the command of area is on area 0. Then add the loopback network. So network of 3.3.3.3, mask of 0.0.0.255, and it's on area 0. So I think we've configured area. We configured now. Now let's also configure area number 14 here. So that is router number 4. Enable, then config terminal. On that router, we are going to give it a process ID of number 4 because it is router number 4. So router OSPF process number 4. Then we'll address the network of 14.14.14.0, mask of 0.0.0.255, area of 0. Then address the network of the loopback, that is 4.4.4.4.0, mask of 0.0.0.255. Sorry. Area here is area 14, not area 0, area 14. So we're going to change that other network, that is network of 14. Tell it area 14, not area 0. So we should be able to see LSS being exchanged. So now the status is now full. The status has changed from loading to full. So meaning that router number 1 here has established an OSPF peer with router number 4. So also we're going to configure this network of 192.4.4 on that same area. So network of 192.168 .168.4.0, and the mask here will be 0.0.0.255. Let me push it where you can see it. .255. Area here is area 14. So with that configured now, we are now on the same router now. We configure the network where area number 45 is. That is a network of 45.45.45.0, mask of 0.0.0.255. Area here is area 45. I think that now we are done because we configured 4 networks, the network of 14.14, this one, a loopback, and also this other network. Now we are on area number 45 on this router number 5. We're going to configure 3 networks, that is for the loopback and for the 2 interfaces. Sorry, in this router, we didn't give it a name, so let's enable config terminal, host name here. Host name here was router number 5. So router process ID here, OSPF process ID number 5. Then network of 45.45.45.0, mask of 0.0.0.255. Area here is area 45. And we attach the network of the loopback, that is 5.5.5.5, sorry, dot 5, I mean, mask of 0.0.0.0, area here is area 0. That is for the network for the loopback, and not area 0, sorry, area 45. I'm used to area 0, I don't know why. We are being told here area where that belong has changed from area 0 that we configured to area 45. So it has successfully changed. And now we configure the network of 192.168.5.0, mask of 0.0.0.255. Area here is area number 45. So we are going now to try to test our network if the PCs are able to reach each other. So first of all, we're going to try to configure, can we reach now the loopback where router number 1 is from this PC here. We're going to try to ping that network. You can see now we are able to reach this gateway here, that is 10.10.10.1. What about the loopback? So ping 1.1.1.1. It's able to reach that loopback because it is held by the OSPF now. Show IP OSPF neighbor. You can see it has established a neighbor with the .4.4. That is 14.14.4. Now let's ping this other PC. From this PC, let's see if you can ping. Let's ping first of all, ping a 1.1.1.1. It's able to reach that gateway, but this area that is connected to the backbone should be able to reach each other, because now while we are on this router here, exit, and we tell it to show IP OSPF neighbor. You can see here the neighbors we have is 2.2.2, 3.3.3, 4.4.4. That is router number 4. But it can't learn about router number 5, because the router number 5 is not directly connected to that area router here, that is area on the backbone area. Now what about on this router number 4? On router number 4, let's do it. Do show OSPF, do show IP OSPF neighbor. You see that the neighbor, it has a neighbor with router 1 and router number 5. So what about on this other router number 2? Enable. So show IP or OSPF neighbor. It has a neighbor with a 1.1 and also a 3.3. So meaning that this PC should be able to ping a .3. Let's see. So ping 3.3.3.3. Several packets are able to go on successfully. To ensure that also this router number 1 can see router number 5 that is on area 45, we are now going to configure what is called OSPF virtual link on this router 1 and router number 4. So you enter on router number 4, router number 1, or you tell it router OSPF process number 1, Then we are going to establish a virtual link with area number 14. So area 14, a virtual link with the virtual IP of, that is the loopback, that is 4.4.4.4, that is router number 4. Then again you come on this router number 4. You tell it router exit. So you can see here, before you went for configure a virtual link on that interface, you can see here, I received invalid packet mismatch area ID from backbone, must be a virtual link but not found from the serial 0. So meaning that the link has been it has sent a message that, oh, there have been some actually changes with the virtual link. So you tell it router OSPF, this is process number 4. Then area here, area 14, and on area 14, it's going to establish a virtual link with 1.1.1.1. That is on router number 1. So you see that. After that, now come to your router number 1 and try to check the neighbors. So do show IP. So you can see here, it has established a peer with the, you see here OSPF virtual. So let's now see. So do show IP OSPF neighbor. When you show it tell it to show OSPF neighbor. Now when you ping our switch numbers, our loopback 0 here, it's able to go through now because of the virtual link. Now the link between those areas are active. Also, when you try to ping 14.14.4, should be able to go on successfully. And now, can we actually ping this PC and this other PC? That is PC, this one and this one. So that is 4.4. So ping 192.168.4.10. Actually, those links are the ping is successful. So again, we're going to check on that our network. So while we are on this PC here, let's try and ping this other PC on that area 0. So come to that command prompt, then ping. We're going to ping 192.168.2.10. You can see now it's a packet is able to reach successful, means that PC3 here is able to ping PC number 1. And what about she also it's able to ping the loopback for router number 5. What about loopback for router number 4? So ping 4.4.4.4 is able to ping successfully. Now come to your router number 1 here, because we already configured a virtual link between router number 1 and router number 4. Now able to reach router number 5 here. Also, this guy can it also ping the other networks? So ping 192.168.2.10 is able to go successfully. So meaning that our network is now fully working. There's one thing you need to know, that area here, area number one, area 0 here, and area number 14, they are able to work without the virtual link because now they are connected to the backbone. So this ABR will act as the router that links area number 14 and area 0. So now when we want to make sure that area 0 and area 45 are able to work is when we configure the virtual link. So there are some of the things that we said that here we need also to configure priority of 255 to make router number 1 as the permanent DR, designated router. So we are going to go into the interface that connect to the switch, and so config terminal. Here the interface that connect, so interface gig 0/0. So IP OSPF priority here will be 255. So let's question and see. So the priority range from 0 to 255. So priority will be 255. So after we configured that, we know that in OSPF there's what is called a preemption. So however, DR and BDR election actually work with the non-preemption. That is, however, how the higher priority you have, the higher priority value you have, and to join the network will not take over the role of the DR. So the network will still remain with the DR that was working initially, however, even if it has a lower DR value. So like here we've changed the DR value. So now we'll require to reset the process ID so that now a new election pop up, so that it will pick up now as and knows that this router is now the DR. So what we are going to do is just to clear the OSPF process on each and every router. So exit. So then after we exit, now we are going to clear OSPF on the privilege executable mode. Not clear, clear IP OSPF. After that, we type process. So say reset all process. Say yes. Now it is picking up again. Also come to this router number 2. So enable. Then you clear IP OSPF. Sorry, IP OSPF here process. Say yes. On this other router also you do the same. Enable, clear IP OSPF process. And also on this other router. Enable, clear IP OSPF process. Then finally on router number 5. Enable, clear OSPF IP OSPF process. Say yes. And go back to your routers here. You can see now the state has changed to full again. So with that done, we are just going now to see now to do the verification and testing again. So we are going back now to your router number 1 here. So show IP OSPF neighbor. You can see here is the DR. We have got the DR other. DR other doesn't it's just a link that is establish adjacency. While now we can see now it's the BDR is for is router number 5. Then again, we are going to check at the OSPF. So show OSPF, show IP OSPF interface. When you show OSPF IP interface, you are able to see now the router ID was 1.1.1. That is the ID of the loopback. We said that a loopback has a higher preference when selecting the router ID. So it will take the highest loopback configured on that router first of all. So if there's no loopback, it will now pick the highest configured IP address, physical IP address configured on that interface, or the manually configured address. And also the protocol line protocol is up, and again anything that you need to see to look at here is a broadcast network. Now you see now the priority, we've changed the priority to 255. From initially the priority was uh, 1. Now the priority has now changed to 255 as we have configured there. So then the state here, it is a DR. So it has permanently been set as the DR. So in case any other router joins the network, it will not override this other DR. And also on this router, let's show IP OSPF interface. You see it here. Its ID is 2.2.2, and the area here is area 0. The priority is number 1. So priority is number 1. So that's about that, guys. And also let's see a display here. So let's test something here. Show IP OSPF database. When you show OSPF database, you can see all the networks that are on that router. It knows about a network of 14.14.0, 45.45.0, 5.5.5.0, 192.168.5.0. So all these are the summaries, all the summaries of all the routes to all the networks in our topology here. So this is a type 3 LSA, and this one is a type 1 LSA. Then this one is a netlink. This is a type 2 LSA. Router link, this is a type 1 LSA. So we can be able to see what the information that is contained in the OSPF routing table there. All these are information that are in the OSPF routing table. And the next now, we are going to see now the virtual link. So show us IP OSPF virtual link. So when you say OSPF virtual links here, we can see here it has established a virtual link with the router number 4, that is 4.4.4. The transit area is area 14, and via the serial interface the cost is 64, and so on and so on. The date and also the hello time are those one given there. And let's again run our last verification. So show IP protocol. So when you show IP protocol, you can see here we are running OSPF process number 4, and these are the routing networks are this one here on different areas. We have got area 14, area 45, and so on, and also commands on router number 2. So show IP protocol. You can see different areas with the different networks. So, and lastly, now show IP route OSPF. When you show IP route OSPF, you can see here, when you see here 0, this one means that OSPF, the routes that have been learned through OSPF. So we have got a network of all these networks and subnets, and 3.3.3, 4.0.0/32, and those one and those one, and so on and so forth, with all these other network which have been learned through OSPF. So that's about that, guys. Now let's pick and see how the PDUs will be traveling here, and on these different PCs. So we want to ping from different PCs and see how we will be able to see those packets traveling. So this is how now the real time. Now let's see. You can see here all the pings are successful. When you see here, this last status here is successful. That is from PC 0 to PC number 3. And from PC number 1 to PC number 0 also was successful. PC number 1 to PC 2 is successful. PC number 0 to number 3 is successful. PC 0 to PC number 4 is successful. From PC number 2 to PC number 0 successful. Also PC number 1 to PC number 3 is successful. So we are going to toggle back and see now how it happens in a simulation way. So we are able now to see how our packets are traveling and how they are get verified. The good thing with Cisco is how they help you use the PDU packets. Now you see it happening physically from the topology. So that's how we implement multiple area OSPF and see how the packets travel and travel back and they get verified. With OSPF, it's very fantastic, very enjoyable sessions. And in case there's something burning and you don't understand, guys, feel free to ask. So you can see here, I tick here, the first packet has gone successfully. Also, another one has come back successfully. So that's how you implement multi-area OSPF. Like in case there's an area, but it is advisable that you ensure that all the areas are connected to the backbone. But in case where there's an area that is not connected to the backbone, use a virtual link to link those two areas. Just a link that link the two areas. It is just an OSPF technology. So thank you guys for watching these videos, and remember to subscribe if you haven't subscribed yet, and give me also a thumb up, and let's meet in our next video tutorials. In next video we are going to look at the now IP version 6. Now we are going to see how can you configure OSPF single area for the IP version 6 and also multiple area for the OSPF version 6. So thank you.